optimization. We're going to go explore what's going on with a beer can. Or a can. Or, well, maybe just a cylinder. I was trying to make it exciting or something. Guess it's not. All right, let's jump into it. I think I got a slide over here. Here we go. Here's our last little one. Actually, I'll probably get you up a couple other little weird, fun ones. So we got a cylindrical can is constructed. Think beer can, huh? Constructed using 100 square inches of tin. All right, that's our constraint, right? You only got this much material. All right, you're not gonna build a 10,000 square foot home and you only got material for 5,000 square feet, right? So that's your constraint. Okay. Yeah, 100 square inches of tin. So if it says square inches, that means we're talking area, right? All right, cool. This amount includes a top and bottom for the can. Thank God, so the beer doesn't spill. All right. So, what is the largest volume such a can might contain? All right, let's go. Let's try and draw one up. Let me see what's going on. Look at my great beer can I'm drawing here. So you got maybe a little suspension of disbelief here. But hey, it's got some sort of height, huh? And then there's something else. Oh shit. Okay. So the question wants the volume. So let's write that down. So if we have a can here, what's the volume of a cylinder? The volume of a cylinder is what is that? So it's the area of the circle that's up top. See the circle that's up top there? It's the area of that circle, pi r squared, times that height. Cool. So there's the volume of a cylinder. It's just the area, or it's just the area of the circle on top times the height. Right? 3 dimensions. Think about all those dimensions we take care of. Well, what's given to us, so there's our equation. We found our equation. We want to now find what's up with that constraint. So that's talking about areas. So what we actually have is, well, we don't just have the can, it has some tops to it too. You got a couple circles. They're the same things, of course. And I imagine that they have some sort of, let's write it in, they probably have some sort of radius in here, huh? Maybe some radius. But this is the same thing that's up here, this radius. Well, we have those 2 circles, because that's the top and the bottom of the can down there at the bottom. But now, how the heck are we supposed to figure out the area of this cylinder? So typically I'd be in a class, I'm actually going to do it right now so you can hear me crumpling it. If you take a piece of paper and you circle it around and you touch it back together till you make it look like a can, right? Now open it up, it's a piece of frickin' paper. So let's imagine we get into this. We're going to get into this right here. We're looking at our cylinder. We're just cutting. Like, let's just cut this thing. Come on, please work. So we just cut it down the center and now we're going to open that can up. Okay, so once we open this can up, I think you're going to end up having it look like a rectangle-ish thing. Well, I'm going to try that one more time. So you're going to open that thing up, and it's going to become a piece of paper, right? So you flatten out the can. Now you just got a flat piece of tin. But oh shit, we don't know what's going on up here. Because we need our base times our height, or our width times the length, or whatever the hell you want to talk about it. But if you go back to that was a piece of paper circle, like you made a circle out of it. This part here, all around it, the circumference of the circle would now be the width or the base of your rectangle. So there we have it. We have these 3 pieces of material, here, here, and here, that need to total up to be 100 square inches. So that's where our constraint's going to come from. So let's set that thing up. We're going to say 100 square inches needs to be equal to, and let's add it up. So the area of our piece of paper, or the tin flattened out, is 2 pi r times h, right? Base times height. 2 pi r times h. There we go. Plus, right? And then we have 2 circles. And the areas of circles, we got 2 of them. So let's write 2 times the area of a circle is pi r squared. Let's stop for a moment. If you're one of the people that are watching this and I said the area of the circle and it did not come into your head immediately that the answer is pi r squared, you need to change that. There will be no more math classes, STEM classes, anything where anybody needs to alert you or tell you that, oh, you need to know the area of a circle. You need to know the area of a circle. Not just to be able to look it up online, get that shit on lock. Because it's going to suck when you get to a test in, say, physics, and you can't do the damn problem because you don't know what the area of a circle is. That's, you've probably known this formula for close to, I don't know, 5 to 6 years minimum. Probably most of us more like a decade. Let's try and get that shit dialed in. Okay, moving on. Get off my soapbox. So what we need to do now is we want to plug into our volume formula right there, right? We want to be able to plug into it, but we don't want to have two different variables. We don't want an R and an H. So I think the best way for us to do this is to solve for H in our constraint. And then we can plug it in, then everything's going to be in terms of R. I don't think we need the slide anymore, so I'm going to give myself a little bit of room to go. So let's start manipulating our 100 is equal to our 2 pi rh plus 2 pi r squared. And let's solve for that h right there. So let's get everything away by subtracting over the 2 pi r squared. So we get 100 minus 2 pi r squared is equal to 2 pi r times h. Well, let's get that 2 pi r, let's divide it on over. What do we got here now? H is equal to 100 minus 2 pi r squared over 2 pi r. And I'm going to simplify this down. I'm going to break the numerator because I know there's a cool little trick that pops out of this. And if you divide it out, you're going to get 50 over pi r minus r. And there we go. We've solved for h. And once we solve for h, that means we can go and plug that thing right back into here, huh? We can go put that into our h, and then we'll have ourselves our equation all set up and ready to be differentiated. So here we go. Let's take our volume. Our volume is equal to pi r squared times h, and instead of writing in h, we're going to put in what we found from above. 50 over pi r minus r. So let's clean it up. Let's expand it on out, and then we can take a derivative on it, right? We want to get it to where it's some sort of like just power rule. We don't want to get too crazy. So let's bring it on through. We're going to find out that our volume is equal to, it looks like that's just going to be 50r on the first one because the pi's are going to cancel. At least one of the r's are going to go away. And then we bring it through. We got minus pi r cubed. Sick! We now have ourselves an equation with just the frickin' radius in it. Not a radius and a height, not having to do a product rule or any of that nonsense. We just get to run right through and take the derivative. So in optimization, this is not related to rates. We take a derivative, we set that shit equal to 0, then we solve so we can figure out whether we have a maximum or a minimum. So let's go. So dv dr, or the derivative, you could write v prime if you want to, is equal to 50 minus 3 pi r squared. Again, not related rates. We're just going to set this shit equal to 0 and solve. Like, yeah, we're almost home. We got it. Did all our work. Solving for r. So we're like 3 pi r squared is equal to 50. R squared is equal to 50 over 3 pi. R is equal to the square root of 50 over 3 pi. Dope. We found the radius. Awesome. And we can just think of that thing as being positive, right? Because we're talking about lengths. We're not going to talk about no negative. So what's the question asking us? What is the largest volume? Shit, we got to find the volume. We found the radius, and we have a formula that's highlighted in blue right over here. It's going to tell us how to get our height so we can plug it in so we can actually go get our volume. So now it's just a matter of plugging things in and not making a silly mistake. And if we want an exact answer, this might be a bit. So there's our radius. Let's go plug it into our height and see what our height's going to be. So our height is equal to 50 over pi times our r minus our r. Well, let's plug our r in and let's see if we can't get it. That's the square root of 50 over the square root of 3 pi. And this is the square root of 50 over 3 pi. And I broke my one down. in the bottom. So let's just go. I'm not going to explain too much on this. So we're going to get 50 times the square root of 3 times pi over the square root of 50 times pi minus, and let's see what happens over here. This gets a little bit algebraically dense. Let's see if I can do this without making a mistake. I highly doubt it. I'm probably going to make some mistakes, so that's how that cancels out. And then you got your root 3, and then you're going to end up with a root pi on the bottom. A root pi on the bottom. But I'm going to want to create a common denominator over here with this root 3 pi. So I'm actually going to do one of these, and bear with me. You can do your algebra any way you want, but this is just kind of the way I'm rolling it through. And now it looks like I have that h is going to be equal to, we got our common denominator of that. Oops, make sure that pi is underneath there. We got 3 of those root 50s minus 1 of those root 50s, so that's going to be 2 of those root 50s. So we got 2 root 50s, but shit, that breaks down even further. So we're going to get, what's that, 10 root 2, so I'll let you figure out why that's true. And then, okay, there's our height. Sweet, so we got our height, and we got our radius. Now I think we can get our frickin' volume. Wow, it's hard to just plug in. Arithmetic's the toughest part of this dang problem. And now we're almost there. We're gonna get our volume. I know it's like this problem will not end. It's pi r squared times the height. Well, we got our height, we got our radius, so it's v times pi times our r squared times our height. So let's plug them all in. There's our root 50 over 3 pi times our 10 root 2 over root 3 pi. What's this equal? So this is going to be pi times 50 over 3 pi times 10 root 2. So our pi's go away here. We're going to end up with 50 times 10, which is going to be what, 500 root 2 over 3 root 3 pi. That's pretty freaking exact. You know what I mean? And I imagine most of us would have just punched it into a calculator already and wrote down an answer. I'd take 2 of your points because I want you to be able to mess around with these numbers. So if we're talking volume and it was in square inches, I think we're going to have cubic inches. Now, hopefully I wrote this thing down. I got the right answer. It looks pretty familiar to me. I think I do have it indeed, but here it is. Fun with it. So this is a rough one. This is not a simple one, long-winded, and not just that the problem is tough. There was just a lot of algebra and a lot of numbers. So I'll see you on the next one.